Right now, we're going to have our scalability discussion featuring Chris McCoy of Storecoin, Dr. Mo Dong, he's the co-founder of Celer, Igor Barinov of POA, Moderator Martin Stroka of DCSF, Yijia Zhang, and Kingsley Advani from Chainfund. Please welcome them. Thank you.
Hello. Great, welcome. So, very, glad to have this very large panel. We've got plenty of time, so we're going to do about 30 minutes of discussion, and then we're going to have some Q&A at the end. So, if anyone out there has some questions, start thinking about it. So, I'd like to start by just welcoming the panel, and maybe you guys can just share a real quick kind of summary about yourself, what you're doing, and then we'll get into some more questions. Yeah, starting with Mo.
Sure. Hi, this is Mo. I'm the founder of Celer Network, and we are working on off-chain scaling solutions to bring internet scale to every blockchain. And we have like a pretty good, basically unified technical stack and innovations on side channel and side chains, and also a coherent design on the crypto economics. You can follow us at Celer Network Twitter and basically Medium posts.
Okay, so this is Yijia. I'm a founder from Origo. We just did a presentation, and we will try to enable the privacy and the private preserving smart contract, and so we also facing some a scalability problem for verification on chain. So so that's the part. Yeah.
Hey, I'm Kingsley from Chainfund Capital. So we're one of the largest early investors in new blockchains. So we were early backers in Thunder Token, Oasis, Zilliqa, and Icon. And we have four main theses. First of all, sharding. So we really think sharding is a core path towards scalability. Secondly, we like hybrid consensus mechanisms. So for example, Thunder Token combines a blockchain with an off-chain accelerator. Oasis, which combines a blockchain with a trusted execution environment, like Intel SGX. We also like privacy. We're big fans of ZK Starks. And also we like novel consensus mechanisms. So for example, Solana, which we recently backed, have a novel proof of history consensus mechanism. We like proof of space-time, like Chia Network and Space Mesh, and also POA, with their interoperable scalability.
Good afternoon. I'm Chris McCoy, creator at Storecoin, powered by dynamic proof of stake. Storecoin is zero-fee, high-throughput, decentralized cryptocurrency, where if Ripple is going after Swift, we're going after ACH and Visa.
Hi guys, my name is Igor from POA. POA is immediately available scalability solution for Ethereum ecosystem. So it's a sidechain, public permission blockchain launched on December 2017. It's a two-way pegged sidechain, one of the kind, since May 10th. So you can transfer assets from Ethereum to POA and back in a decentralized way. Also, we think that scalability is not only about transactions per seconds and amount of computations you can do in one block, but more about making developer ecosystem more friendly to scalability solutions, because there are some scalability solutions like Ethereum Classic, which are available a long time ago, right? And like 50 times cheaper than Ethereum, but developers not using them. So we are focused on building tools for developers, which are available on sidechains, like interoperability solutions and blockchain explorers.
Great. So I think we've heard a lot about scalability. People see it as one of the major factors or trends in the marketplace, and oftentimes it's applied in relation to Ethereum. And so we've seen a lot in the media, probably in development circles as well, about different solutions that people are proposing for it. I'd just like to get you to share your thoughts specific to Ethereum and some of the scaling solutions that they have and what you think about their viability. Starting, maybe Igor, maybe you could field that.
Okay, so in recent Vitalik's tweet, he mentioned like 5 existing directions for scalability solutions, like more chains, which I like, and the diversity of those chains, Plasma and change in existing Ethereum client not related to changing security properties of this client, and lots of existing solutions. But I think it's important to understand what is available now, and how can developers can use it at the moment, right? So that's what we're trying to make on our side, how to make scalability solutions usable now. And when you have it, you think, okay, how to make people use it, right? And that's a big question. Okay, you have a token on an Ethereum mainnet, how you can move your token to a sidechain, to scalability solution. And now, and you think, oh, let's create a new token, and how you will connect this token, right? And lots of questions. And I like that different companies and different groups are trying to figure out different ways. But from my perspective, future in diversity and interoperability. So projects like Polkadot, Cosmos will be drivers of these innovations in the Ethereum space. From one side, like a relay type system, and also projects like POA Bridge will allow create independent bridges for individual tokens for their own use cases, right? If I am a project and I have my ERC20 token and I want to get access to more scalable infrastructure, most likely I don't care about someone else's tokens, right? I only care about my token and how to make my computation less expensive, how to make them faster, and so forth, right? And also how to get some specific features. On previous talk, we had the talk about zero-knowledge proofs on chain, right? Now computations for on chain for zero knowledge, which is available on Ethereum, is very expensive, and it's made for purpose, right? Because it was a kind of new technology, and it was a way to protect like general infrastructure from very expensive operations, computation expensive. But from my perspective, it's 20 to 30 times more expensive than it should be. And can we make it less expensive? Yes, where? On sidechain. And sidechain can be scalability not only for existing transactions, but also for new types of transactions. So that's one.
Well, it's tough to maneuver a $50 billion airplane midair. And our analysis is there's potentially just layer 1 solutions that can be done, optimizations to increase throughput with its current 21,000 validator set. And we don't see a lot of talk about that. So we think other layer 2 things are maybe premature, but we wish them the best of luck.
So Ethereum does have the biggest developer community, and it was very early. But it is suffering from scalability challenges with about 10 to 15 transactions per second. So Ethereum's currently got a proof of work, proof of stake hybrid, but it's gradually moving to proof of stake and sharding. Because they do have all of the adoption, it's quite difficult for them to transition to a scaling solution because they've already got a lot of usage. But I do think over the next year or two, Ethereum will start to develop out some of their scaling solutions. I think minimum viable Plasma should be coming quite soon. And yeah, we'll see how Ethereum can scale, particularly with its current adoption.
Yeah. So there's several ways for Ethereum to actually enable this scalability. And they plan to have like lots of like layer 2 solutions to actually scale. And usually the blockchain user has like a trilemma, like a security, scalability, and like this kind of security. So when you do like a layer 2, usually the problem is like how do you verify the stuff, and you enable lots of like computation. You actually decrease a little bit about the security. So it's like a pretty for Ethereum, they also need to think about like how to, because currently it's like a pretty safe, and then they need to enable this kind of safety to a level. So they have idea about like a stateless sharding and like a Casper, and the community actually block it a lot actually to make it move a little slow, and they have to move slow and then to make the community happy. So I'm looking forward to the Casper and see how it can scale with this kind of and their future plan for the stateless sharding. Yeah.
Cool. So I think the question is like, what is the scalability solution out there, and specifically maybe for Ethereum, but in general for blockchains. So I think if we want to view this question, we need to view this from like two aspects. One is on the technology aspect, and the other is on the market, right? So on the technology aspect, fundamentally speaking, all the scalability solutions are making trade-offs one way or another, right? So now we need to basically understand what kind of trade-offs are these solutions making, and at what stage are these solutions, like the trade-offs made is most making sense to the market. Right, so on Ethereum there is like on-chain scalability solution, kind of like a new consensus algorithm, though that is not like basically so much focused on the scalability per se. But in general, in blockchain space, there are a lot of new consensus algorithms being proposed on the what people call layer one blockchain space, and on top of that, there is also sharding. But for all these on-chain solutions, they are basically making two kinds of trade-offs. They are making the trade-off on decentralization versus scalability, and they're also making trade-off on finality versus scalability. So sometimes the finality is like a more complex concept to explain. But what we think, we from like Celer Network's point of view, think that one big component that is still being missed by a lot of people, and also have a much faster go-to-market speed, is off-chain solutions. Right, so off-chain solutions, what people are commonly referred to as layer 2 solutions, but we really don't like the layer 2 name because it feels like it's kind of an optimization that is optional. But what we think is that even if with all this kind of a decentralization versus like scalability trade-off done for layer 2 network, layer 1 blockchains, layer 1 blockchain scalability will have an upper bound. It cannot sustain the level of like scalability we want this blockchain ecosystem to eventually sustain. And therefore, we need to look beyond the on-chain solutions and start to think about what kind of off-chain solutions there are. And and there are many technology that enables these off-chain solutions, but also at the same time, we need to also start to think about like what kind of like off-chain crypto economics there is that actually makes sense instead of just like doing a medium of payment token or stuff like that. So I think from just to a quick summary here, from a technology point of view, people are very focused on the on-chain solutions right now, and we should also start to think about like off-chain solutions in general. And the reason we think that is the case is because that can actually bring us to a much faster mass adoption in terms of go-to-markets for these solutions, basically.
Okay, great. Yeah, so that's a great kind of segue and into kind of the next topic. So I'd like to hear about new solutions that people are proposing, maybe starting with Kingsley, since you've actually looked at a lot of, as the only VC on our panel, you've looked at and talked to a lot of entrepreneurs that are building out new solutions. I'd love to hear what you've seen in terms of trends and then the focus on scalability from entrepreneurs. And then it'd also be great to hear, anybody can jump in and talk about your own solutions, how you're seeing the market, and what you're seeing as the major breakthroughs.
Sure. Firstly, I think there's many more scaling solutions that are coming up now. I think researchers are realizing that scalability is probably the biggest problem in blockchain at the moment. So more and more researchers are building new blockchains. Across that spectrum, firstly, sharding is, so Zilliqa is building a sharding blockchain, and they have already released their testnet. So they're one of the first blockchains to implement sharding, although it is transactional-based sharding. I think Ethereum does plan to roll out state sharding with Plasma. Secondly, a broader topic, as I mentioned before, is hybrid consensus mechanisms. So this is when researchers combine blockchains with other forms of consensus. So for example, Thunder Token is combining a blockchain with an off-chain accelerator to validate transactions more quickly. Oasis is combining a blockchain with a trusted execution environment, so a piece of hardware like Intel SGX. We also have a lot of novel consensus mechanisms. So POA, for example, which is doing interoperability between blockchains. We also have proof of space-time, proof of history. So there's all sorts of different consensus mechanisms. It is still quite early to tell which ones will work. I think we will tell over the next year or two. But I think it will be increasingly important to test out high-throughput decentralized applications on these new blockchains. So for our portfolio companies, for example, we encourage new blockchains to test out high-throughput dApps in the early stages. For example, running CryptoKitties on them. And yeah, we will only really tell which blockchains can scale once we start getting high-throughput dApps to test on these new blockchains.
Great. Chris, I think you have some novel approaches. Maybe you'd like to share a little bit more about how Storecoin is approaching this?
Yeah, thanks. We've really taken a kind of a research-intensive approach at what this problem, why it's important to begin with, and we look at our current truly decentralized chains maxing out at 20 transactions per second, and hopeful that will increase with layer 1. We think that it's paramount. Layer 1 is optimized before layer 2 is even a solution. Cross-shard communication becomes a massive challenge when you're a Fortune 500 company and your data's in another shard, and those are things that we're not discussing yet. But for us is you look at Visa. Visa does 24,000 transactions per second. That's about 1,600 different network endpoints controlled by one central server, but that's quite a lot of throughput. And Tencent, Alibaba does about 225,000 transactions per second. So we say, well, with this new payments technology, where do we need to be? And we think that hundreds and thousands of transactions per second is where all projects should be looking at. So for us is we notice similarities in running various consensus systems in our own machines to kind of learn what could a better system look like, or a system that could actually have throughput with decentralization. So we took a different approach to it. We instead of sort of working on one block at a time, as we have what we call parallel block production. So as the current block is being finalized, we actually begin the next block. And we take what used to be sort of chain forks and orphan blocks, and we start taking the next set of incoming transactions and we start appending them to those next set of blocks. So as the current set is finalizing, the next set is being processed. And so this, in our early test, gives us sub-second block production. And we expect to release a testnet in the fall with real test results. But that's an approach that we're taking that's novel and unique, and could be wrong. We recognize this, but it's definitely an evolutionary leap.
Great. And Mo, maybe you could go into a little bit more detail. So you talk about, on Celer Network, you guys talk about internet scale, off-chain seems to be a major emphasis. You've also even apparently got some thoughts on hardware usage and the role of that in this. But I think the phrase is even leaning to, I think the phrase billions of transactions. I saw that somewhere.
Oh, right.
Website,
Yeah.
Maybe you can explain that one to us.
Sure, no problem. So now, I guess like we're talking about scalability today. Let's ask a first question of okay, so we all know that blockchain today is slow, but how slow? Like, what is the end goal here? Like, how much faster we actually need to get to become for the blockchain system to become a mass adoption system? Should we target for Visa scale? Should we target for Tencent, Alibaba scale? Should we target something else? Well, so here's like one way of thinking about this question, right? So, if we think about what happened in the past 100 years, is that we changed the way of delivering information from, using carrier pigeon networks to internet, right? So we realized the speed of light information transfer. We realized that we changed the information transfer from a discrete event to continuous event. However, in this last 100 years, what is staying the same is the value transfer. Value transfer still happens in segregated financial silos, and yes, it is pretty fast, but it's still like very much discrete event. It's still like not matching the speed of information transfer. Now, however, if we think about what is like human's economic activity, human economic activity is really the information transfer and value transfer and the conversion between information and value, basically. So apparently, information transfer is lagging behind. So by how much? Right? So if we look at the statistics now, internet itself is delivering 2 million emails per second, 65K Google searches per second, 75K YouTube video plays per second, and about 53 terabyte data delivered through the internet per second. Now, if we want to, what do we mean by bring internet scale to blockchain is that we want to match, we want to have like the blockchain match the speed of the information transfer. Let's assume, like just do a back of envelope like calculation here that, if we want to have like one value transfer event happen, let's call that event kind of a transaction, right? So let's say one value transfer event happened every 1 kilobyte of data delivered, then we're looking at about 53 billion transactions per second requirement here, right? So, however, the problem about that is like for all the on-chain solutions, as long as there is a consensus involved, no matter how horizontally scalable and all that caveat we throw in the pot, there's always this scalability bound, approximately, maybe it's like actually more complex than that, but like approximately, it's very hard to exceed the order of transactions that can be processed by a single server, right? So that's where we think that, we need to bring most of the transactions from the on-chain consensus, from actually needing to incur on-chain consensus to actually putting them to the off-chain world. And that's what Celer brings. And there are some existing on-chain solutions like, off-chain solutions like Lightning Network for Bitcoin. But for Celer, we're doing a more generalized off-chain solution that can not only support just like simple payment, but also enable the capability to run any arbitrary contractual logic on this off-chain platform, what people call like off-chain smart contracts, basically. And on top of that, we care a lot about the infrastructure of this off-chain world, that is basically how to deliver this off-chain payment or conditional payment that bound to any contractual state efficiently. And on top of that, we touch the developers, right? We want people to actually write scalable, decentralized applications, and then we have like an open SDK and also a runtime system for people to actually start to use this, optimized and scalable off-chain applications. So that's kind of like what our view is in terms of how to bring mass adoption to this blockchain ecosystem by using off-chain solutions in a technology side. But it also has like important trade-offs of economic trade-offs, and that part, like that might be running into a longer discussion, basically.
Okay,
yeah.
Got it, great. Yijia, maybe you want to share a little bit from your perspective what Origo, how you guys are approaching this?
Yeah, so we're also using like an off-chain idea. So the problem is like when you calculate this stuff on-chain, it's pretty hard to guarantee the privacy because everything is calculated there, right? So you have to throw the stuff to off-chain. But the problem is like for off-chain, as I just mentioned, it's like the security problem. So usually for state channel, if there's no conflict and then no dependency, then it's pretty good to go, and then just say, okay, the result is there, and then commit on-chain, then problem got solved. But the problem is like if there is conflicts, and then if there's something, how do you verify it? How do you still guarantee the on-chain security, but still doing the calculation off-chain? Then we came out with this kind of zero-knowledge proof. It's like you do something off-chain, but you just provide a proof, and then people by verifying this proof, you can guarantee, okay, this calculation is done correct. And the interesting part for zero knowledge proof is like for example for ZK Snark, it's like the calculation could be really complicated. It even takes several days, but the verification on chain is still pretty fast. So it's like a constant time and then for verification, but okay, it takes several days for off-chain to calculation. So this enable lots of like, okay, let's say we want to enable this privacy, or you just want to say this will take time off-chain computation. I don't want to do it on-chain. I just do it off-chain, and but later when we verify it, okay, bang, actually done, pretty correct. So that's something also another way to extend this kind of scalability.
Okay, great. And feel free to jump in at any time if you hear anything or if you want to kind of be contrarian. So in the meantime, it'd be great to hear from Igor about the role that interoperability plays, since that seems to be a major emphasis. You guys have built this bridge, and it'd be good to hear about what the role that plays in terms of scalability.
Yeah, and tomorrow I will have a presentation about POA Bridge, and today is 30 days ago we launched this first two-way packet bridge between two Ethereum networks, and it was risky for many from many standpoints because those are like 5 smart contracts in 2 different networks, and you have to solve some problems take responsibilities for this token, and someone should take this. So we were very nervous before, and we did lots of security audits, and also figure out that this off-chain solutions can bring some like legal implications we don't think about when we're working on-chain, because when we are working off-chain, there are entities who operate these off-chain transactions, and if we do something with tokens of something which have monetary value, it can be money service business and some other words we don't want to hear, and like AML, KYC, suspicious activity reporting, Bank Secrecy Act, and all that stuff, right? So off-chain scaling solutions can bring like more questions about legal side of these computations, especially if it's related to tokens, right? POA Bridge is basically an off-chain solution. It's like it's a server with threshold signatures between a group of independent validators between 2 networks, and they operate on using a designed protocol, and they lock and unlock native coins on POA network and mint and burn ERC20 representation of this token on Ethereum network, because we cannot create new native tokens out of thin air, right, on a network. And maybe it's not impressive stuff, but for me it's impressive. About 20 million of POA tokens bridged from network to network, and now this smart contract holds about 3.5 million of POA tokens, which is quite a large amount of money if you transfer it, if you convert it into other cryptocurrencies. And it's it's in public space. It's not. It's owned by token holders, and transfers achieved using consensus of independent parties. It's not the ideal bridge, right? It cannot solve all problems of token transfers. It cannot transfer ERC20 for now. We're working on this and cannot transfer some other scalability type of tokens like ERC7 to 1 for CryptoKitties type of games. But what I can say after a month of operations, like we launched this bridge and did nothing, and people just use it, right? The token connected on both sides to exchanges, different type of exchanges, and one big problem it solves is how to get access to liquidity of Ethereum mainnet for new networks, for side chains, for all these new consensus algorithms. And second question is how to move tokens back, right? To side chains to get access to these computations. So basically we have 2 on-chain solutions and 1 off-chain solution between them, but which operates on trustless, semi-trustless, and decentralized way. I think interoperability is more important than scalability, because scalability is we have scalability, right? We have if we think about Ethereum, we have Expanse, Ubiq, Classic, POA. Anyone can launch a POA-based network at the moment. Well, Cosmos soon, and some other EVM-based networks, Qtum. What else? Maybe I forgot, but lots of EVM, rootstock, right? So we have all these scalability solutions, and they're very inexpensive, but how to make them usable. So from my perspective, it's interoperability first, and second is developer experience. So like, if you want to, just think about this. You want to like, as a dev shop, you want to make a token for your client, and client asking to verify this token on Etherscan. As you're saying, oh, sorry, I'm on Classic. Oh, no Etherscan for Classic. Yeah, so that's how are you going to sell it, right? So you will recommend Ethereum all the time, right? You will not recommend other scalability solutions because you will not get money, right?
Yeah, Igor and I, we talked about this. We're both building our own protocols from kind of ground zero, and there just is not a lot of infrastructure in the space. It's pretty easy to take 15 minutes and spin up an ERC20 and throw some cool marketing around it and go to the moon. It's incredibly challenging to, from ground zero, rethink the future of payments and programmability in the payments sector. And so we sort of struggle with that. There's not a lot of tools out there, and we have to do a lot of things behind the scenes that are not necessarily directly on the path to execution of the core consensus algorithm to enable these ecosystems to go. So the world's much bigger than Ethereum. Ethereum's an incredible experiment that will have a huge future ahead of it. It has to solve layer 1 before it goes to layer 2. That's our take. But there's room for a lot more innovation where new scalability solutions will exist with decentralization. And I think that's why we're all here. In the absence of true decentralization, you could sort of make the case that it's cheating or it's just like fake. And so those take novel approaches. So I think the scalability conversation, we're going to be having it in 10 years.
Great. And do we have a microphone in the audience? Do we have any questions from the audience? This is going to be the Q&A time. Does anyone have a question? If not, we'll just keep, you can raise your hand and we can bring the mic to you. Yeah, was that you? Yeah.
Sitting on 2 mics.
So if you have a question, maybe just bring it up to this gentleman. Okay, in the meantime, maybe if you guys want to share more about something other than your own project, a solution that you've seen out there, right? Other than your own that you've been really impressed with, where you see it as having been very promising.
Yeah, our project is a big fan of Rayblock's Nano. I think they've taken a unique approach with sort of 8 validators that have these representatives, near zero fee, very high throughput. That's a project to take a close look at if you like scalability and novel solutions.
Great, great. Yeah, who else has got some thoughts on that?
Sure, I really like Oasis and their white paper Ekiden. So they've not only built out their blockchain, but they've also tested 5D apps. So in their white paper, they've got a lot of the performance reports, so their throughput, their latency, and their transaction fees. So it's worth reading, and it's one of the most impressive white papers I've read.
So I'm interested in those kind of like a DAG-based in parallel consensus for improving the on-chain scalability. Because like currently in between this kind of block time, you can only you cannot parallel those stuff. And this is a great idea to see how DAG can go far, how far it can go, and to solve the problem. And the second is like you think about scalability, but the problem is like when you scale, there's lots of transactions per second. How do you store that? So there's like an idea. It's like using kind of like using zero-knowledge proof to actually compress the stuff. So so the problem currently for blockchain is like you record all of the history, and later you can replay it. And so if you replay it in between a period of time, you replay it and then building a proof, then you doesn't need to store all of the history. You just need to, you have some full node, but you doesn't need to have all of the node at full node. So that's also a great idea to see. Yeah.
So I think there are two categories of two categories of solutions. One is like on-chain, and then there's like whatever is not consensus is what people call off-chain solutions. And I think for all these off-chain solutions, many of them are like actually very complementary to each other and can work together. So I would just name one example here, that is TrueBit. So TrueBit is a pretty cool project that is focusing on the computation itself. Like basically, let's say you're computing something super hard on blockchain. You don't want like the EVM to compute it for you, so you just compute it offline and then put the result on the chain and do like a binary challenge, basically. So that particular piece of work that we actually like start to look into and use in Celer as well, because for us, in many cases we also want to like accelerate the settlement of the channels and side chains, and for those cases, like that kind of a style, not necessarily using the TrueBit itself, but that kind of a style of like commit and challenge is something that is very interesting, I would say. But like again, I think anything that is other than the optimization or improvement on the consensus algorithm is going to interoperate and cooperate, like basically in the scalability world.
Great. Yeah, and Igor, yeah, go ahead.
Yeah, I'd like to add that from what I see from other projects, many projects trying to implement their own new consensus algorithms, right? It's like implementing your own cryptography sometimes, right? But also, like, there is a gap between academic and open source project at the moment, some people can just take good enough existing algorithm, or they can try to implement something that exists only in papers, right? Like we, on our side, for us, underlying consensus was not the most important part, but we spent some R&D onto exploring how to implement some academic research, and we just finished the first phase of implementing very promising asynchronous BFT protocol, Honey Badger BFT, and did some tests and figured out that this is actually that can be very beneficial for the network. And also when you implement some novel academic paper, you can get some insights about what your network is and how can you improve it and figure out to split something. Let's say in our use case, we never thought about splitting reward per block and creation time of block. And now I understand that with Honey Badger we can get, if we don't have transactions, we can have very, very fast blocks. But if we have lots of transactions, we can have increase in transaction per second. But reward can be calculated in smart contracts. And if block time took, 1 minute to create because of some DDoS attack on the network, validators will receive reward every 5 seconds, how it's described into economic model. Right? So that's something you don't think about when you don't implement new ideas, and that's what I would like to see from other projects. Not to create your own cryptography or consensus algorithm. Look into but don't implement hash graph because it's very protected by patents. So all other algorithms, I know they're much less protected. Want to add something?
Yeah, I mean, I think that it's not just scalability we need to get right. We need to get decentralization right. We need to get the efficient allocation of block rewards across a complex network. And to get all those to work in a high throughput environment where you have latency across nodes. I think you mentioned about who stores the data, right? There's innovation there. There's innovation in layer 2 if it's sort of like natively baked in, I think, into the protocol itself. So there's a role master nodes can play where they actually have real utility, not just sort of economic upside for stakers, but they actually provide a service for layer 2. But to get this technology correct, we have to be very honest. It's hard, and it's long term, and it takes wild experimentation, and you have to be willing to be wrong, and you have to be willing to go against consensus, or we call it status quo. And I think next generation projects that are coming out post Affinity, post Tezos, are doing that, and we're seeing that on the ground layer. So if anyone knows of a cool project that we haven't talked about here, please tell us. We love to study everything really, really carefully. And the last thing I'll say is we've done a pretty thorough analysis of modern day consensus algorithms. So if you go to storecoin.com/compare, there's a pretty good data set there that we validated in terms of transactions per second, decentralization, transaction fees, governance systems, security systems, patents. It's open source. Use it however. If you find an error, tell us. But it's a pretty good place to go to just get really good research. We've put a lot of time into that.
Great. We've got a minute left. We got a lightning round, closing thoughts. Mo, anyone? Kingsley, final thoughts?
I think in the future we'll see many different blockchains, and I see people building applications plugging into different blockchains like APIs.
Well, so I think like there has been a layer 1 blockchain competition or war going on for a while. But this year and later this year, I'm hoping that like basically the off-chain scaling solution can bring blockchain application to actually achieve like mass adoption. That's our goal.
Great. All right. Well, that's all the time we have. So thank you very much to our panel for joining us.